in order to crack WEP, we need to first capture a large number of packets. This means that we'll capture a large number of IVs. The IVs, because they are short, they will be repeated. Therefore, we'll be able to use a tool called AirCrackNG to run statistical attacks and crack the web key. So we're using AeroDumpNG to capture the data, and we've seen how to do this before. Then we're using AirCrackNG to analyze this data and break the key. Let's see how to do this in practice. So I already have my wireless adapter in monitor mode, and it's called Mon0. I've also already run AeroDumpNG to list all the networks around me. And as you can see, I have only one network using WEP. This is called TestAP3. And this is my actual network that I use every day. I've just configured it to use web to make this lecture. The main reason why I'm targeting the network that I use daily, because like I said, for this to work, we need to capture a large number of packets, and therefore we need a busy network, a network that gets used constantly to capture a large number of packets. If the network is idle, then the process is a little bit complex, and I will cover that in the next lecture. So for now, let's focus on the simplest form, which is how to break into a busy network. So I'm going to copy the BSSID of this network, and I'm going to run AeroDumpNG against this network only. So I showed you how to do this before. I'm going to do AeroDumpNG. I'm going to do --BSSID to specify the BSSID of the network. Then I'm going to do --channel to specify the channel of the network, and we can see it's running on number 1. And I'm going to do --write to store everything that we capture into a file, and let's call this file basic web. And then I'm going to specify my wireless adapter in monitor mode, which is Mon0. So we ran this command before in the targeted sniffing lecture. All we're doing is we're running AeroDumpNG against a specific network with this MAC address, with this channel, and we're storing everything in a file called basic web. I'm gonna hit enter, and as you can see, AeroDumpNG is working against my target network. And if you notice, you'll see the data in here is increasing really fast. So this is something that I told you I'll talk about it later when we were talking about AeroDumpNG, because I didn't want to talk about IVs at that early stage. So basically what you see under the data column is the number of useful packets that contain a different IV that we can use in order to crack the key. So the higher this number is, the more likely we will be able to crack the key. As you can see, this number is increasing very fast because, like I said, this is a busy network that is being used at the moment by my own computers and my own devices. If yours isn't increasing fast, then don't worry, we will tackle this problem in the next lectures. So for now, we're capturing a lot of data, and this should actually be enough to crack the key. So what I'm going to do, I'm going to go down to my other terminal in here, and if we actually list the files, you'll see that we have the capture file that we specified in the right argument, and like I said, we're always interested in the .cap file. So all we have to do right now is do step 2 in here, run AirCrackNG against the file that we captured in order to crack the key. So I'm going to do AirCrackNG, followed by the file name, which is basicweb01.cap. I'm going to hit enter. And as you can see, it's telling us that the key is found. So let me cancel this here. And right now, we can connect to the target network, which is called TestAP3, using this ASCII password. So you can literally just copy this and paste it, or you can connect using this key. Now, in some cases, you will not see this ASCII password. That's why I'm going to show you how to connect using this key right here, because you'll always get this. So I'm going to copy this, and I'm just going to paste it here. You can paste it anywhere in a normal text editor or anywhere you want. And all you have to do is remove the colons that we see in here between the numbers. So I'm going to remove this one, I'm going to remove this one, and this. And now we can just copy this. And just to show you, I'm actually going to connect from my host machine. You can connect from Kali, but when we enabled monitor mode, we killed a lot of processes, and sometimes even after you restart these processes, getting connected to your target will be a little bit buggy. So it's best to literally just restart Kali and connect again. So just to save all of this time, I'm going to connect from here. I'm just going to click here. I'm going to connect to test AP3, and I'm going to paste the password. So I'm just going to click on show the password to show it to you. Again, the same password, we just removed the colons. I'm going to click on join. And as you can see, we managed to connect, and we can test this connection by going to Google. And perfect. As you can see, it's working, and we managed to break the WEP encryption. In the previous lecture, we seen how easy it is to crack WEP. All we had to do is capture enough data and then run aircrackng to crack the encryption and give me the key. Now, one problem that we could face is if the network is not busy. If it's not busy, then the number of data will be increasing very slowly. Therefore, we're going to have to wait for a while before we have enough data to crack the key. So let me show you an example. I'm just going to run aerodumpng here and list all the networks around me. And you can see I have my test network, my test AP in here. It's using web. And if you look under the data, you'll see that it's at 0 and it's not increasing. And even if it's going to increase, it's going to increase very slowly. Which means that I'm going to have to be waiting for hours before I can crack this network. So a solution to this is to force the AP to generate new packets with new IVs. Now, before doing this, we need to associate with this network. So what I mean by associate is we need to tell this network that we want to communicate with it, because by default, access points ignore any requests they get unless the device has connected to this network or associated with it. So don't get this mixed up with connecting. We're still unable to connect to the network because we need the password to be able to connect to the network. But what we're doing right now is literally just telling the target network, look, I want to communicate with you. Don't ignore my requests. That's all we're doing. So it's something similar to what happens when you just click on the network when you want to connect to it. You still haven't put the password, you're just telling the target network, I want to communicate with you, please don't ignore me. So in this lecture, I'm going to show you how to associate with the target network so we can communicate with it. And in the next lecture, I'm going to show you how, once associated, we can inject packets into the network and force the number of data to increase very quickly. First, I'm going to run aerodumpng against my target network, which has this BSSID. So I'm going to copy it, and we're going to use the exact same command that we've been using so far. So we're going to do aerodumpng --BSSID followed by the MAC address of my target --channel followed by the channel which my target is running on, which is 6. And we're going to store all of this, so we're going to do --write, and we'll call this file ARP replay because that's the name of the attack. And then I'm going to put my wireless adapter in monitor mode, which is mon0. So a very simple command that we've done before. We're using aerodumpng to capture data from a network with this MAC address running on this channel. We're storing everything in a file called ARP replay. I'm gonna hit enter, and as you can see, it's running against my target. and notice the data is increasing really slow, or it's actually not increasing at all right now. Now, to associate with this network, we're going to use a program called AReplayNG. So we're going to type AReplayNG followed by -- fake auth because we want to do a fake authentication attack. We're going to put 0 because we only want to do this once. We're going to do -A to specify the MAC address of the target network. So I'm going to paste it. I've already copied it. Then we're going to do -H to specify the MAC address of my wireless adapter. And to get the MAC address of my wireless adapter, I'm going to do ifconfig. And it's the first 12 digits of the unspec field. Usually, you'd see it after the ether, but when you enable monitor mode, it'll show up like so. So I'm going to copy this, and I'm going to paste it here. And I'm going to replace the minuses with colons. And that's it. It's done. And finally, I'm just going to give the name of my wireless adapter in monitor mode. So a very simple command, we're using AReplayNG, which is a tool that can be used to run a number of attacks, and we've seen using this with the deauthentication attack. We're telling it that we want to run a fake authentication attack. We want to do this once. We're giving it the MAC address of my target network after the A. Then I'm giving it the MAC address of my wireless adapter after the H. And finally, I'm giving it my wireless adapter in monitor mode. Now, before I run this, notice in here under the auth, we have nothing, and we don't have any clients showing up in here at the bottom. Now, if I hit enter, you can see under the auth, it's showing up as open, and you can see we have a new client here associated with the network. If you look in here, you'll see this is the MAC address of my target network, and right here is the MAC address of my wireless adapter. So right now I am associated with the target network, and if I send it anything, it's going to accept it and it's going to communicate with me. Again, I am not connected to the network. I still can't use the internet. I'm literally just associated with the network so I can communicate with it. Now, in the next lecture, I'm going to show you how we can communicate with this network in a way to force it into generating new packets with new IVs, which will allow us to crack the key very quickly. Now that we have associated with our target network, we can start communicating with it and it won't ignore us. So now we can go and start injecting packets into the traffic to force the access point to generate new packets with new IVs. This will increase the number of data really quickly, allowing us to crack WEP networks in minutes, even if the network was not busy like the one that we are targeting right now. Now, there are a number of ways to do this, but in this course, I'm going to explain the most reliable method, which is using an ARP request replay attack. I actually explain other methods in my network hacking course, but they are a little bit more complex and have less success rate. So this is the most reliable method, and it should work against most networks if you have a good signal and a good wireless adapter. So the idea behind this method is to wait for an ARP packet, and I'll talk about ARP in more details later on. So for now, just think of it as a special type of a packet that we're going to be waiting on. Once this packet is sent in the network, we're going to capture it and retransmit it. Once we do this, the router is forced to generate a new packet with a new IV. So, by repeating this process, we will be forcing the router to continuously generate new packets with new IVs. Then, once we have enough data, once we have enough IVs, we can run ARcrackNG exactly as we seen before and crack the key. So let me show you how to do this in practice. Now, as you can see, I'm already running AeroDump-ng against my target network, and I have already associated with it as shown in the previous lecture. So the only thing that's left right now is to run the ARP replay attack in order to inject packets into the traffic and force the router to generate new packets and increase the number of data. To do that, we're going to use areplay-ng again, and the command is actually going to be very similar to this command right here. So I'm actually going to copy all of this because I'm lazy, and I'm going to clear this and paste the command here. Now, there are only a few things that I need to modify. First of all, I don't want to run a fake authentication attack, so I'm going to remove all of this. And I want to run an ARP replay attack. Also, this attack does not take a number, so I'm going to remove this number. And I'm also going to replace the A with a B. And we're done. So if you look at it, you'll see it's actually very similar to this command right here. We're using areplay-ng, but instead of doing a fake authentication attack, we're doing an ARP replay attack. We're giving it the MAC address of my target network after the B instead of the A. Then we're giving it the MAC address of my wireless adapter after the H, which is identical to this. And then we're giving it my wireless adapter in monitor mode. Now, I'm actually going to associate again before I do that. And then I'm going to hit enter here. And what's happening right now is my wireless adapter is waiting for an ARP packet. Once there is an ARP packet transmitted in this network, it's going to capture it and it's going to retransmit it. Once it does that, the access point will be forced to generate a new packet with a new IV, and we'll keep doing this, forcing the access point to continually generate new packets with new IVs. So you should just wait for it right now. We're literally just waiting for an ARP packet to be sent in the air. And as you can see, the number of data is increasing now very, very quickly, which means that we actually managed to capture an ARP packet. This ARP packet got retransmitted, forced the router to generate a new packet with a new IV, and we are continually doing this process, forcing the router to generate new packets with new IVs. So right now we can go ahead and run aircrack-ng to crack this network. And before I do that, I'll actually just associate one more time, and then I'm going to do aircrack-ng and give it the name of the file which we're storing the data in, which is called arpreplay01.cap. So I'm going to hit enter, and you'll notice the cracking process right now will actually require more data packets. The reason for this is I've actually modified the settings of this network so that it uses a 128-bit key, because in web you can either use a 64-bit or 128-bit key, and obviously the 128 key is longer. Therefore, I actually modified the key length for this lecture to make sure it's the longest key possible, and as you can see, we still managed to get it within about 47,000 packets. We have the key right here in ASCII, and we have the key in here in hex, where we can use after we remove the colons. So perfect, now we managed to crack the target network. It was idle, as you could see, there was no data being sent, and we managed to do this by forcing the target access point to generate new packets with new IVs. In the previous lectures, we've seen how to crack the WEP encryption in minutes, even if the target network is not busy. Now, in the next lectures, we will talk about cracking WPA and WPA2. First of all, before we start talking about how to crack these encryptions, it is very important to understand that both of them are very, very similar. The only difference between them is the encryption used to ensure message integrity. WPA uses TKIP and WPA2 uses an encryption called CCMP. In any case, this does not affect the methods that we're going to use to crack WPA and WPA2. Therefore, all of the methods that I'm going to show you from now on will work on both WPA and WPA2. Now, both of these encryptions came after WEP, and they were designed to address the weaknesses in it. Therefore, both of them are much more secure, and cracking them is more challenging. So, before we start talking about how to crack them, I want to cover a feature that, if enabled and misconfigured, can be exploited to recover the key without having to crack the actual encryption. The feature is called WPS. It allows devices to connect to the network easily without having to enter the key for the network. So it was designed to simplify the process of connecting printers and such devices. You can actually see a WPS button on most wireless enabled printers. If this button is pressed and then you press the WPS button on the router, you'll notice that the printer will connect to the router without you having to enter the key. This way, the authentication is done using an 8-digit PIN. So you can think of this as a password made up of only numbers, and the length of this password is only 8. So this actually gives us a relatively small list of possible passwords, and we can try all of these possible passwords within a relatively short time. Once we get this PIN, it can be used to recover the actual WPA or WPA2 key. So as you can see, with this method, we are not exploiting WPA or WPA2. We are actually exploiting a feature that can be enabled on these encryptions. So for this to work, first of all, we need WPS to be enabled on the network because it can be disabled. Also, it needs to be misconfigured, so it needs to be configured to use a normal PIN authentication and not a push button authentication. If push button authentication is used, then the router will refuse any pins that we try unless the WPS button is pressed on the router. Therefore, the method will not work if push button or PBC is enabled. So in most modern routers, PBC comes enabled by default, or WPS will be disabled by default, so this method might not work. But because WPA and WPA2 are so secure and so challenging, it is always a good idea to check if WPS is enabled and try the method that I'm going to show you to crack the network. If it fails, then you can try the other methods that I'm going to show you after the next lecture. Okay, now that we know what WPS is and how it can be used to recover the password for WPA and WPA2 networks, let's see how to do that in practice. So, right here I have my Kali machine. I've already enabled monitor mode on my wireless adapter on Mon0. Now, usually we use AeroDump-ng to see all the networks around us. But right now, we want to see the networks that have WPS enabled, but because like I said, it's just a feature and people can turn this feature off. So, first of all, I'm going to use a tool called Wash to display all the networks around me that have WPS enabled. So, we're going to do wash --interface and give it my interface in monitor mode, which is Mon0. So all we're doing is wash is the name of the tool, interface to give it the interface, and Mon0 is my wireless adapter in monitor mode. If I hit enter now, you'll see it'll list my network straight away. Now I pressed Ctrl C to cancel this, similar to AeroDump-ng, because it'll keep running unless you cancel it. And you can see this is my target network. It's called Test AP. It's giving us the vendor of the hardware used in this network, in this access point. The LCK tell us whether WPS is locked or not, because sometimes WPS locks after a number of failed attempts. So right now this says no, which means that we can actually go ahead and try to guess the pin. It's giving us the version of WPS. It's using version 1. The signal strength is in here, the channel, and the BSS ID. Now, I explained the meaning of all of these things before in my AeroDumpNG lecture, so I'm not going to talk about them now. If you forgot the meaning of any of these terms, please go back to the AeroDumpNG lecture. Now, this network actually uses WPA2, so just to confirm this to you, if I go here to my host machine and just try to connect to it, you'll see that it's telling me that this uses a WPA2 password. But like I said, we don't care if it's WPA or WPA2 because we're going to be exploiting a feature in these encryptions, which is the WPS feature. So now that we know our target network uses WPS, there is a good chance that this attack will work against it. The only reason it might fail is if the target uses PBC or push button authentication. Like I said, if the target uses PBC, then it will refuse all the pins unless the button is pressed on the router, and therefore this attack will fail. The only way to know is to literally try this attack and see if it works. So I'm going to copy the MAC address of this network, or the BSS ID. And the first thing that I'm going to do, similar to what we did with WEP, I'm going to associate with the target network using a fake authentication attack. So basically, I'll be saying, I want to communicate with you, please don't ignore me, so that when I run the attack, the network will start accepting the pins and not ignore me. So to associate, we're going to use the exact same command that we used when we did it with WEP. So we're going to use AReplayNG. We're going to tell it I want to run a fake authentication attack. We're going to give it the delay. So this is the time to wait between association attempts. Previously, we set it to 0, and we had to do this manually every now and then. Right now, I'm going to set it to 30 so that we associate with the target network every 30 seconds. Then I'm going to do -A to give it the MAC address of my target, and -H to give it the MAC address of my wireless adapter in monitor mode. And we've seen that we can get this by doing ifconfig and copy it from here. We said it's the first 12 digits. And I'll just replace the minus with the colon. And finally, I'm going to give it the name of my wireless adapter in monitor mode, which is Mon0. So I explained this in details before. That's why I did it quickly. If you don't remember how I did this, please go back to the fake authentication attack lecture. So the command is ready now, but I'm not going to execute it. I'm going to go down to the bottom terminal and run Reaver, which is the program that will brute force the pin for me, and only then I will associate with the target, because otherwise AReplayNG will fail to associate with my network. So I'm going to move to this terminal right here. I'm going to clear the screen, and we're going to run Reaver, which is the program that's going to brute force the pin. So it's going to try every possible pin until it gets the right pin. Once it has the right pin, it'll use it to compute the actual WPA key. So using Reaver is very, very simple. It's very similar to everything we've been doing so far. So first of all, we have to type the program name, which is Reaver. Then I'm going to do --BSSID to give it the MAC address of my target network. So I'm just going to paste it. Then I'm going to do --channel and give it the channel of the target network, which is 1. Then we're going to do --interface and give it my wireless adapter in monitor mode, which is Mon0. So a very, very simple command. We're using Reaver. This is the name of the program that will do the brute forcing for us and give us the key. We're giving it the BSS ID, the MAC address of my target. We're doing --channel to give it the channel that my target is running on. And we're doing --interface to give it the name of my wireless adapter in monitor mode. I'm also going to add 2 more options. I'm going to add -VVV to show us as much information as possible. This is really helpful. If it fails or things go wrong, we'll be able to know what's happening, why things are going wrong. And I'm also going to do --no associate to tell Reaver not to associate with the target network because we're already manually doing that in here. So Reaver can automatically do this step right here for you, but I've seen that it fails a lot. Therefore, it's actually better to do it ourselves manually here and then tell Reaver not to associate. So now I'm gonna hit enter to get Reaver to work. And I'm gonna go up to the top terminal and I'm gonna hit enter to associate with the target network, telling it please don't ignore us, so that Reaver at the bottom here can brute force the pin and try every possible pin until we get the correct pin, which we'll use to get the password. Now, as you can see, right now I'm getting an error, and this is actually a bug with the latest versions of Reaver. So if you get this bug, this means they still haven't fixed it in the latest version, so it's better to go back and use an older version. I'm gonna include an older version that works perfectly in the resources of this lecture, so you can access it from the top left of the lecture. If you tried Reaver and got this error right here, then go ahead and download this older version. Right now I already have it in my downloads right here, so you can see I'm in Home Downloads, and I have it right here called Reaver. So what I'm going to do is I'm going to clear this again, and I'm going to navigate to my downloads, so CD downloads. I'm going to list, and you can see we have it right here. Now it's already in green for me, but for you, you'd want to change the permissions of this file to an executable. So you'll have to do chmod +x Reaver. This will make it an executable. Once it is an executable, you can run it by doing ./ followed by its name, so Reaver. Then you can do the exact same command exactly like I just did it with the one that comes pre-installed in Kali. So I'm actually just going to go back to what I had, and I'm just going to go to the start of the command and put ./. So when we put the ./, we're basically running the file that is in the current working directory. We're running this. We're not running the normal Reaver file that is pre-installed in Kali. Then we're using all of the options exactly the same way that we were using it with the built-in one. I'm gonna hit enter. And as you can see right now, Reaver is trying the pin 1, 2, 3, 4, 5, 6, 7. And perfect. You can see the pin was actually 1, 2, 3, 4, 5, 6, 7, 0, so it's a simple pin. It actually came with this pin, so I didn't manually set this pin. My router came from the factory with WPS enabled with this pin. So like I said, this still works, but again, not against all routers. From that, it was able to discover the WPA key, which is UAU RWSXR, and the name of the router is TestAP. So I can literally go ahead and connect with this password, and I'll be able to connect to the network and see and decrypt all of the packets sent in the air. Now, if WPS is disabled on your target network, or if it's enabled but configured to use push button or PBC, then the method that I showed you in the previous lecture will not work. Therefore, you will have to go and crack the actual WPA or WPA2 encryption. And like I said, when these encryptions were designed, the developers knew about the weaknesses in WEP, and they made sure that they properly fixed these weaknesses. They actually did a pretty good job at this. Therefore, we cannot use the same method used in WEP to crack WPA and WPA2. So in WPA2, the keys are unique, they're temporary, they're much longer than what they were in WEP. Therefore, the packets sent in the air contain no information that is useful for us. So it doesn't matter, even if we capture 1 million packets, we can't use them to crack the key. The only packets that contain useful information are the handshake packets. These are 4 packets transferred between a client and the router when the client connects to the network. So, in this lecture, I'm going to show you how to capture these packets, and in the next lectures, we'll see how to use them to crack the WPA or WPA2 key. First of all, as usual, you'd want to run aerodump-ng against all the networks around you. I've already done that, and as you can see, this is my target right here. It's using WPA2, and this is the MAC address. I'm gonna copy it. And the first thing we'll do is just run aerodump-ng on this network and store the data in a file, exactly the same way that we used to do it with WEP. So we're just going to do aerodump-ng --bssid and give it the bssid of my target --channel and give it the channel of my target, which is 1 --write to specify a file name to store all the data that we're going to capture in, and let's call this WPA handshake because we're going to capture the handshake. And finally, we're going to give it my wireless adapter in monitor mode, which is mon0. So very simple command. We've done this multiple times by now. We're using aerodump-ng. We're giving it the MAC address of my target after the BSSID. I'm giving it --channel to specify the channel of my target. I'm using --write to store all the data in a file. This file will contain everything that we capture. So if we capture the handshake, it'll be in this file. And finally, I'm giving it the name of my wireless adapter in monitor mode. So now I'm gonna hit enter. And as you can see, aerodump-ng is working against my target network. And right now, all we have to do is literally sit down and wait for the handshake to be captured. Like I said, the handshake is sent when a client connects to the network. So we'll literally have to sit down and wait until a new client connects to the network. Once a new client connects, we will capture the handshake, and you will see in here aerodump telling us that the handshake has been captured. Alternatively, we can use something that we learned before, which is a deauthentication attack. We know using that attack, we can disconnect a client from the network. So we can do this for a very short period of time. We can disconnect this client from the network. He will automatically connect once we stop the attack. Therefore, when he automatically connects, the handshake will be sent in the air and we will be able to capture it. This way, we will not have to sit down and wait for someone to voluntarily connect to the network. So we've seen how to do this before, and it's going to be exactly the same command as we did it before. We used aeroplay-ng, we did --deauth, then we specified a really large number of packets to keep the client disconnected for a long period of time. This time I'm going to set this to 4 to only send 4 deauthentication packets. This way, my client will be disconnected for a very short period of time. They won't even feel that they got disconnected, but this is enough for the handshake to be sent because they will be disconnected, they will automatically connect, and when they do that, we will capture the handshake. Now, the next argument we want to set is the MAC address of my target. So we're going to do -a followed by the MAC address of my target. Then we're going to do -c followed by the MAC address of the client that we want to disconnect. So it's this client right here. I'm going to copy, paste it here, and finally we're going to give it the name of my wireless adapter in monitor mode, which is mon0. And we are done. Again, I've spent a full lecture on this command explaining what a deauthentication attack is, so if it's a bit confusing, please go back and revise that lecture. Basically, all we're doing is we're using aeroplay-ng to run a deauthentication attack to disconnect this device for a very short period of time. That's why I'm setting this to only number 4. Then I'm using -a to specify the MAC address of my target, -c to specify the MAC address of the client connected to this network, and then I'm giving it my wireless adapter in monitor mode. Now I'm going to hit enter and keep an eye on this side right here. You'll see the handshake will be captured in here. So we're going to hit enter. The authentication packets are being sent. And perfect, as you can see, once the client connected again, we received the handshake. So now we can quit arrow dump ng, so Control C, because we have the handshake now. It is stored in the file that we set after the write option, which is called WPA handshake. And in the next lecture, I'll show you how this handshake can be used to get the key for the network. From the previous lectures, we learned that when it comes to WPA and WPA2, the only packets that contain some information that can help us with cracking the key are the handshake packets. And in the last lecture, we learned how to capture the handshake and store it in a file. Now, the handshake does not contain any information that can help us to recover or recalculate the WPA key. The information in it can only be used to check whether a password is valid or not. Therefore, what we're going to do is to create a word list, which is basically a big text file that contains a large number of passwords. Then go through this file, go through the passwords one by one, and use them with the handshake in order to check whether this password is valid or not. You can actually download ready word lists from the internet, but in this lecture I want to teach you how to create your own word list, and in the next lecture I'm going to explain to you how the word list and the handshake are used in order to recover the password, and we'll see how to do that in practice. So in this lecture we're going to learn how you create your own word list using a tool called Crunch. This is a really handy skill to have under your belt if you want to be a penetration tester, because you're going to face a lot of scenarios where a word list attack can become very handy. So using the tool is very simple. All you have to do is just put the name of the tool, and then you specify the minimum number of characters for the passwords to be generated. Then we're going to specify the maximum number of characters for the password. Then you specify the characters that you want to generate passwords from. For example, you can put all lowercase characters, all uppercase, you can put numbers, digits, or you can just specify a smaller number to make the word list smaller. You can also use the option T, which is an optional, to give a pattern. So for example, let's say that you were looking at the person while they were typing their password, and you've seen that the password will start with an A. So you can tell Crunch that the password will start with an A, and then give me all possible combination of passwords that start with an A. And after that, we use the -O option to specify the file name where the passwords are going to be stored. So we have a small little example here that will generate a list of passwords that start from 6 characters to 8 characters and contain these characters right here. So it's going to create combinations of 1, 2, 3, ABC, and the $sign. And it's going to store it in a file called word list. And these passwords are going to start with an A and end with a B. And it will generate passwords based on all possible combinations between the A and the B. So all of the generated passwords will always start with A and end with B. So let's have an example of the tool. Now the tool actually have a lot of options other than what we've seen so far. So if you just type in man crunch, you'll see all the options that you can set, and you'll see detailed description about all of these options. So it's actually really good. You can go ahead and spend some time to get familiar with the tool. Now I'm going to show you the example, and based on the example you'll be able to run all of these commands. But if you want to run or create some advanced word lists, then I highly recommend that you go over this. One of the really cool options that I want to highlight is the -P option. The -P option tells Crunch to generate passwords that don't have repeating characters. For example, when you specify all lowercase characters, you specify A, B, C, D, it will start by generating passwords made of A, and then A, B, B, and all of that. So when you do this, Crunch will actually ignore these type of passwords, and it will only create passwords that don't have any repeating characters. And that will reduce the size of the word list from the number of characters to the power of the length to the number of characters factorial. If you scroll down, you'll actually see more examples of commands and the type of word lists that will be created. So again, you can have a look on these and get yourself familiar with. Once you're done looking at the man, you can just press Q and you'll be out of it. And we're gonna run our command here. So we're gonna use crunch. And again, I want to generate passwords of minimum of 6 characters and maximum of 8 characters. And I want them to contain combinations of ABC. And let's say the digits 1, 2. Now in here you can actually keep listing things. You can list characters, you can list uppercase characters, or even symbols if you wanted to. Once you're done with listing the characters, we're going to specify the file to save it to, and we're going to save it in a file called test.txt. So the command is very simple. It's crunch, minimum length of the password, the maximum length of the password, followed by the characters that we want to use to generate passwords from, and then O to the file that the passwords are going to be stored in. I'm going to hit enter. And as you can see now, it's telling us that it generated 448,000 passwords approximately, and they're all stored in a file called test.txt. Now, the size of the file is 4 megabytes. And now I can open this file by doing cat test.txt. And as you can see now, we can see all the passwords that have been generated. I'm going to Control-C out of it because it's a huge file. And as you can see, it actually contains all possible combinations of ABC 1, 2. I also want to show you an example of using the -T option. So I'm going to set this to only 6 to 6, so it's only 6 characters. And we're going to use the -T option, which is the pattern option. And I'm going to tell it that I want the password to always start with an A. And then I want you to fill all possible combinations of characters between the A and the B. So I want passwords that start with an A and end with a B. And in the middle, at the @ sign, you can fill all possible combinations of ABC 1, 2. Gonna hit enter. As you can see now, the number of passwords is much less. It's only 625 passwords because I've narrowed down the possibilities of passwords. Again, if I do cat test.txt, you'll see that I have all the passwords right here. So this is it. Tool is really useful, can be used in many scenarios. I highly recommend that you spend some time with it and also have a look on some of the existing word lists out there on the internet. Now, from the previous lectures, we learned in order to crack WPA or WPA2, we need to first capture the handshake and second have a word list which contains a number of passwords that we're going to try, and hopefully one of them will be the password for the target network. So right now I have both of these components and we are ready to go and crack the password. To do this, aircrack-ng is going to unpack the handshake and extract the useful information. The MIC right here, or the message integrity code, is what's used by the access point to verify whether a password is correct or not. So it's going to separate this and put it to the side, and then it's going to use all of the other information right here combined with the first password from the word list to generate an MIC, another message integrity code. And then it's going to compare this MIC to the one that's already in the handshake. If the MIC generated using this information plus the first password is the same, then the password used to generate this MIC is the password for the network. Otherwise, this password is wrong and it'll move to the next password. Again, it'll do the same. It'll use all of this information combined with this password, generate a new MIC, compare this new MIC to the one that's already in the handshake. If it's correct, then this is the password. If it's not, then it's going to move on to the next password. And it'll keep doing this through all of the passwords in my word list. If any of them generates the right MIC, then this is the password for the network. Otherwise, we won't be able to get the password. That's why the success of this attack really depends on your word list. So let's see how to do this in practice. Right now I have my word list right here. It's called test.txt, and I've actually manually added my password to the end of the list right here, just so that when I run the word list against the handshake, I will actually find the password, because the word list did not contain my password by default. I also have the handshake file right here, as you can see, and all of this is in my home directory, which is my root directory. So if I do ls in here, you'll see I have the word list and the handshake file. So we're ready to run aircrack-ng. So we're going to type the name of the program as usual, followed by the name of my capture file, which is wpa-handshake01.cap. So far it's identical to the way that we used to use it with WEP. The only difference right now, because this is a WPA2 network, we have to specify a word list with the -w option. And the name of my word list is test.txt. So very simple. Aircrack is the name of my program. wpa-handshake01.cap is the name of the file that contained my handshake, and I'm using -w to specify my word list file. I'm gonna hit enter, and as you can see now, aircrack-ng is running through the word list, testing each word in the word list one by one, as shown in this diagram, calculating an MIC based on this information and the word list, and then if the MIC is correct, it's going to tell me that this is the password. Now the speed of this depends on your processor and the size of your word list file. So if you have a huge file, obviously it will take you longer time. There are also online services that you can try where you upload the handshake, and they have huge word lists and they have supercomputers to run through these word lists and try to give you the password. Unfortunately, I can't share their links with you, but you can easily find them on Google if you search for them. And perfect, as you can see, we managed to find the key. It's telling us the key is found, and this is the key to the network. And this is the correct key because, as you know, this is the same key that we got when we exploited the WPS feature. So now we can go ahead and connect to the network, and we'll be able to run all of the cool stuff that I'm going to teach you in the post-connection attack section. Now this is the only practical way known so far to crack WPA and WPA2 keys. There are methods to speed up this process, so you can use the GPU for cracking because it's much faster than the CPU. That's if you have a GPU. You can also use rainbow tables. You can also pipe the word list as it's being created in Crunch to aircrack-ng. This way you can create bigger word lists without using any storage on your computer. There are also methods so that you can pause your cracking process and then come back after a while without losing your progress. But the main idea is the same. The only way right now to crack WPA and WPA2 is through a word list attack. You can use social engineering, however, to get the password using an evil twin attack where you trick one of the users to give you the password. This is actually all covered in my advanced network hacking course. The cracking using the GPU, piping Crunch to aircrack-ng, getting the password using an evil twin attack, and much more advanced network hacking techniques. If you're interested in that, then I highly recommend you have a look on my advanced network hacking course. Check out the bonus lecture of this course, the last lecture of this course. It contains links to all of my other courses and a comparison between them. Okay, so through all the previous lectures, we've seen all the weaknesses that can be used by hackers in order to compromise WIP, WPA, and WPA2 encrypted networks. We've seen how they can use these weaknesses to crack the password and get the actual key to the network. We also seen that attackers are able to deauthenticate or disconnect any device from any network without the need to know the key to that network. And in the previous lecture, we've seen how we can modify the settings of our routers so that we can increase the encryption of our network, increase the security of our networks so that hackers can't use the attacks and get the password. Now, in order to apply the settings that we talked about in the previous lecture, you need to be able to access the settings page for your router. Now, each router has a web page where you can modify the settings for the router, and it's usually at the IP of that router. So first of all, I'm gonna check and get the IP of my computer or of my device, and I'm just gonna do ifconfig lan 0. And as you can see, this is the IP of my computer. So I'm going to open my browser and I'm going to navigate to 192.168.0, and the IP of my computer was 25. Usually the IP of the router is the first IP in the subnet. So this is the subnet. At the moment it's 192.168.0, and I'm just going to add number 1 because that's the first IP in the subnet, and that will take me to the router settings page. And as you can see, it's asking me to enter a username and a password. Now, routers come in with a pre-specified username and password. You can check what's the default username and password, and then I highly recommend you change them after that. So usually it's written in the manual. So check the manual, see what's the default username and password, and then you can log in. Now, in some cases, the attacker might be doing a deauthentication attack against you, so he might be preventing you from connecting to your network wirelessly. So what you can do is you can connect to your router using a cable, using an Ethernet cable, and when you do that, then the attacker cannot use a deauthentication attack to deauthenticate you or disconnect you. So you'll be able to access your router settings using the wire, and then you can modify your security settings and change the encryption, change the password, do all the things that I recommended in the previous lecture in order to increase the security so that the attacker will not be able to attack your network and get the key. Now, the settings of each router are different. They depend on the manufacturer and even the model of the router. But usually the settings, the way that you change the settings is the same. And like 90% of the cases, the router is always at the first IP of the subnet. So all you have to do is you get your IP using ifconfig command like we did here when we got it, and it was 192.168.0.25. That's the IP of my device. And then I changed the last 25 to number 1 to the first IP, and that is the IP of my router. Now, I'm going to navigate to the wireless settings. Now, as you can see, there's a lot of settings that you can change for your network, and we're concerned with the wireless settings at the moment. So, as you can see, my wireless is enabled. You can change the name of the network, you can change the channel, and the bandwidth and all that. So I'm going to go to the security, and as you can see now, I'm using WPA encryption with WPA or WPA2 authentication, and the encryption using AES and TKIP. And if I go on WPS, you can see that the WPS is disabled, as we said now. So basically, I'm not using web, so they cannot use any of the attacks that we spoke about that allow you to crack WEP encryption. I'm using WPA, which is much more secure, and I disabled WPS, so they cannot use Reaver to determine my WPS pin and then reverse engineer my password. The only way that the hacker can access or get my password is by obtaining the handshake first and then use a word list to find my password. Now, my password is very random, even though it actually doesn't use numbers or digits, just letters, but it's very random, so there is a really small chance of someone being able to guess that password. Now, there is another thing that I'd like to show you here is the access control. And using this, you can add policies. So you can add an allow policy or a deny policy. And using that is based on the MAC address. You can specify MAC addresses that you want to allow to connect to your network. You can also specify MAC addresses that you can deny from your network. So for example, You can just, if you don't have many visitors coming to the house, or if you're in a company with a specified number of computers and you want to allow a number of computers to connect to that network, then you can just ask the people, get their MAC addresses, the people that you want to allow, and add them in an allow list. Now, even if someone has the actual key, the right key for your network, and they don't exist in the whitelist or in the allow list, they will not be able to access the network. You can also add a deny list, which is if you want to deny a certain computer or a certain person that you think are suspicious, you can just add their MAC address in the deny list and they will not be able to connect to your network. So this is about it. As I said, the settings page usually look different. The names might be called different names, as in the names for each of these tabs. But usually the main thing is you should be able to access the router settings using the subnet IP and add in number 1, which is the first IP at the end. And if you're being attacked, if you can't connect to your network at all, then just use a cable and modify the settings like we discussed in the previous lectures. In this section, we're going to talk about post-connection attacks, so attacks that you can do after connecting to your target network. Now, it doesn't matter whether the target network is a Wi-Fi network or a wired or an Ethernet network. It really doesn't matter. As long as you gained access to this network, as long as you're able to connect to it, you'll be able to do all of the attacks that I'm going to show you in this section. Now you'll notice once connected, you can do so many cool things. So you'll be able to gather detailed information about all of the clients connected to the same network. You'll also be able to intercept data